Hi everyone! My name is Quentin Adam. I have this weird Twitter handle which was available everywhere, which was great. And then someone stole me from Pokemon Go, and I was sad. So if you find someone with this handle name on Pokemon Go, please ping me. Maybe you have seen me on YouTube because I made a lot of conference or video. And maybe you don't know my actual work, which is leading a company called Clever Cloud, Clever Cloud. And we're a very simple service, which as a developer, you just write code, git push, and we deploy it, monitor it, update system dependency, collect the log, relaunch what fails, make the auto-scaling, manage security, network, everything. So it's really easy to use, and it's available on our true European cloud, so we don't give you data to Trump. And we also have something you can install on your own infrastructure, or on OVH, or on Amazon, or anything else. So that's what we do. Let's go to talk about data. Data are becoming more and more big, and a few years ago, everyone was talking about big data, and basically the whole world got hit by NoSQL and big data, and a lot of new database engines pop out and starting to be interesting. And many developers just discovered that managing data was applying what we call the CAP theorem every day. So when you store data in a distributed system, you have to decide if you need consistency, network partitioning management, or availability. And you can pick two, but not pick three. This is the eternal debate of everyone in the distributed area speaking about what we can do everywhere. And when you choose a database, you need to know if you need transaction, if you need data consistency, if you need schema. Maybe you want to add some constraints because many people will touch to the DB. Maybe you need to have an event flow. Like anything can be an interesting point to look around when you choose a database middleware. So when you discover the NoSQL world, everyone go and rush to the NoSQL world. It was so fun. Who have played with MongoDB here? Who has still MongoDB on production here? Yeah, fewer. So we discover that storing data in a NoSQL world was not so easy because storing everything like garbage was not so easily to request, and even just put the data can be complicated. And we rediscover the comfort on some the old database world, like transaction, or I am sure that the data is written on the disk. This kind of stuff which is really useful when you write data. But when you try to request or analyze data, it can become complicated. We all know, like 10 years ago, we all buy the MapReduce architecture system. So who have written JavaScript with the MongoDB stuff, like MapReduce stuff, the JavaScript function? And we'll find it like it was so cool. Yeah, to be real, it was a little bit painful. We will all buy this. Then Mongo pushed the new aggregation framework, and you can use also Elasticsearch, which is its own decent stuff way to request stuff. So basically, requesting the data becomes a little bit more complicated than what we think, and we all go back to SQL. If you look around, Cassandra launched SQL, which is basically SQL on top of Cassandra. Hadoop project to have SQL are like JavaScript framework popping every day. So you have Hive, you have Phoenix, you have Impala, you have many stuff. And even in new kind of DB, you have many DB who actually try to have SQL pattern. Like if you're going to the time series database environment, you will find that anyone try to have SQL-like syntax. Because SQL is really, really interesting and expressive way to say, okay, I want this kind of data. While we were all running away in the NoSQL world, someone was improving the old DB we know and working on that, which was really great. So, do you know Postgres? Who don't know Postgres? Okay, cool. Postgres is a very old project. It started in the last centuries. And at the beginning, it's a project from Berkeley, and it was called Ingress. And Postgres got major iteration. It basically missed the point of the first open source database environment where MySQL got the major role. And it becomes more and more trendy these days. If DB engine ranking is not so perfect, what we can see here is there is more and more user of PostgreSQL this last few years. And it becomes something very popular with a large number of contributors using it and various companies who help the development of Postgres and build stuff around that. For the old talk, I will use an example, which is a playlist management application where you have multiple backends like Deezer, Spotify, YouTube, I don't know what, and a playlist history. So the entities I will have to use is a user, playlist, and the track history, where I will put all the tracks and link to the playlist. If you look at it, like every track is becoming from Deezer, Spotify, YouTube, or anything else, the data is not common to everyone. So I will have to normalize it on some A or not. And what is need is I will need schemaless stuff, okay? And apart from schemaless, I will need what we call arbitrary data depth. It means like in JSON, you can have a JSON with some field, but some field can be a JSON, or can be another JSON object, and another JSON object. It's called arbitrary data depth, that you can have many children. So the data is complex. So, and we know that all the data will be already in JSON because we will request like API and we get JSON. We will not use a NoSQL database on this project for a real reason, because if I say to you, okay, I need a unique email for every user. It's called constraints, and constraints in the NoSQL world can be very complicated to apply, and you will have it on PostgreSQL. If you try to do this kind of a request, like which are the tracks played at from 8 to 9 on weekdays, which is a complex stuff, it will be very complicated to process it to NoSQL because the complex data is very complicated to explore. But if you try to add stuff like in Paris area, which means that we will need to have geo-reversing stuff on the IP of the user or anything like that, or so yeah, complex data is very hard, or by mail user, which will link the data to the people, which is actually using relationship in the data store. This is where SQL can be very interesting because we will need the actual ability to link data to each other. And when you start to have order by or pagination inside the UI, it can be very, very, very difficult to have it in the NoSQL world. But SQL have been made to display data to the user. At the beginning, SQL have been made to be used by the end user. So you can actually see the data, and sometimes, and this is another advice when you choose a data source, sometimes you think about what will be the analytics of your data, but you don't think of the day-to-day usage of display it to the user. So it can be interesting to store the data in multiple places. For example, have all your data in Postgres and stream it also in Elasticsearch. So you will aggregate your data and make your statistic and dashboard on Elasticsearch, and you will have your day-to-day usage on Postgres, okay? So we use Postgres on this project for a real good reason. First, we'll create the tracks table. So we say the tracks table is a UID as the primary key, and we have a playlist ID as a UID, which is linked to the playlist table, and we have the user ID also linked to the user table. Just to say it like quickly, we use UID and no serial here. Why? First, because if you want to use serial and say something about your data, you will actually leak some business information outside in the URL to the user, which is not good. If you're using the serial to count things, many people actually using the last ID to count how many stuff there is in the table. If you are in the database and try to explore it, all the table will have an entity called 2, because you're using the same ID on all the database, which is not good if you made a mistake, okay? And to be honest, I don't think it's a good idea that the primary key is generated by the database. I prefer the primary key is generated by the software, and we push it to the database. So when you actually create a user, you create a new random UID and push it to the database with it. Because when you give it to the database to generate, you have this kind of weird code where you insert and select last item. It's not proper. Your database is only storing the data, it's not creating data. Globally, this big problem of ID is put name on things, which is a computer science problem. And we have written an article long time ago about that, which is summarizing everything. So you can grab it online and pass it to all your team, because we want to kill the serial stuff. So that's it. So that being said, we can create the track table, and we continue. So we will use the track status. And we have a name, the interval, and the plate, and the create. So first, you have to use enum, because enum is very good. For example, when you create a database of user, you can say this is a male or a female with a Boolean, which is absolutely not good. You use an enum. When you use enum, it will be semantic, and you can add more stuff later. So use enum. And every time you put date inside the database, use date with timestamp, okay? Because also you will have some weird problem. So, and the last field we create is called track data. And we say it's called JSONB. When we say it's called JSONB, we say to Postgres, we will put JSON here, because Postgres is about to process JSON. In Postgres, you have two types of JSON. You have JSON, which is basically the text stored, and it passes it every time in it. And you have JSONB, which is already parsed, to be simple. So basically, use JSONB. Never use JSON, simple, okay? If you look at it in SQL, you can actually get actual JSON. So there, I put a string and I convert it to JSON, and as you can see, it's actually real JSON. So we have the tracks table, and you had a user ID, but don't care. When you request JSON in Postgres, you have several operators. So you just have your payload, it's a JSON, you have the arrow, you get the key you want, and you will get it. And each time you need it, you can use it. Like, for example, you can try the existence of something. So you add some JSON, you convert it to JSONB, and you use the operator, which is question mark, to see if it's actually existing inside your database. But each time you do that, you can use SQL function. So for example, I can say, I will take the payload, I will get the date, put it inside a timestamp with a time zone type inside Postgres, and execute date trunc here to just keep it the month, okay? So what is the really interesting stuff here is all the data you put inside the JSON are not like a payload you cannot touch. You can use it in all your SQL requests and actually make data science on top of it, okay? So you have plenty of capacity. You can have stuff to determine the length of an array. You can have a map or any manipulation data here. You can filter. You can use JSON pass, which is the same thing like XPath in the XML to get the data you want. You have pretty filter to have like everything. So it's really interesting, and you can use lots of interesting function of PostgreSQL on top of your data. For example, this is the temporal function of SQL, would have plenty of function you can use on the data which is actually in the JSON. Just take it, pass it, and use it directly in your SQL. Which lead you to use, for example, something like count. In NoSQL, it can be really complicated to have a count. There, you just use SQL, because you can have a where clause, digging inside the JSON, comparing stuff, and get you all the entities, and just count it, which will be really simple to do, compared to write a complex JSON of the MongoDB aggregation framework, for example. Everything you do with a JSON can be put in an index. So for the people who don't know what is an index, is every time you store stuff in PostgreSQL and you know you will request oftenly on, you can create an index which is a kind of pre-calculation of all the data you will have to compare. And everything you put inside the JSON can be compared using an index there. So it's really useful because it can be really fast on your application to use it. And you have many tools who can suggest you the index just reading the logs of the query you actually do on Postgres. To be able to do that, you will have to choose the database and the version of the database you use. And to be honest, the ORM you're using can be frustrating. And it will not be your best friend there because you're going out of its leagues. Managing JSON data is not what it does. So sometimes it's not a good idea to use it. And when you go on the full usage of PostgreSQL, you will have to build your own SQL, take the data, extract it, and managing it. When you will do that, many times you will discover that JDBC driver, and especially the Postgres driver, is not complete. There is some type of Postgre return it cannot pass, and it's kind of a problem. So there is a workaround. The workaround is not very nice, but it works well. So you just say, okay, everything inside my select, my query, will be going to JSON, and you actually get all the data to get your table in JSON, and when you have it in JSON, you just add Jackson, JSON, or any other JSON parser you already have, and manage the data with that. So it kind of switch off your problem of JDBC driver, and it makes you able to reuse some code you already make for your API. So it's kind of good. And the overall the cost of performance to the database is really thin because it's streaming. It's a very, very good function, so it's not a big problem. Okay, you have more and more data, and your query is starting to slowing inside Postgres. There is a good news: is Postgres since version 10 have add a parallel queries, so it splits the queries between multiple CPU and add multiple workers to work on the query. You just have to just put it some value which is non-zero to max parallel worker and max parallel worker pair gather, which means the number of workers you can use with only one connection to the DB. And when you use that, you will be able to see if your query is actually working. So for that, it's like everything in SQL world when you try to understand. You type explain your query, and then after you ask for the query plan. And as you see, you say like, I will use 4 workers to do that and split it on parallel. So you have nothing to do here. Just see how you can split your query to parallel workers. You can also add multiple extensions to PostgreSQL, especially one which is an ability to use CUDA and the GPU to do all the hash and scan operation. I never use it. It's called pgstorm. It seems very fun. I want to use it one day, but I never have the use case to use it. But it seems to be a very interesting point if you have multiple hash to do. And for example, if you're building a Bitcoin tracker, it can be a good usage of the stuff. If you start to having more and more data and want to expand on many more nodes and having more availability, you need to go on many stuff. So the first possibility is have master-slave classic replication style. So basically, you have to split your request between the write on the master and the reads on the slave or on the slaves. Or you can use a tool like PagePool who look all your requests and make the split from himself. But more, you can use more replica for specific purpose. Just explaining. If you have a data scientist in your team and it makes very big SQL queries to your database, very long, very heavy SQL queries, you don't want it inside your master because it will slow down the production, maybe kill the master node. You don't want that. So you will put a slave which will get all the data by streaming. You don't need the BI to be up to date. So you can say to the slave, you don't need to be uptime all the time. So the master will not assure that it I've written to the slave to say the query is okay, because it's only a mirror, it's not mandatory to be there. And you will just using this slave only for the BI. And going further, the people at PostgreSQL are creating something we call the logic replication, which is the ability to say, I will create a publication, which is this table on this table on this table, and I will create a subscription on the other side on the slave, which is get only this table. And you will be able to monitor. So you can replicate only part of your DB and not the entire DB. And as you know PostgreSQL have row level access control. So you can control the access in the data per row and not only per table. And I think the publication subscription model of replication will be able to use this model pretty shortly, which is very exciting, because you will be able to filter the data you stream to a replicate. So maybe you can stream only the data for a partner or something like that. You can also use what we call notify, which is the ability to Postgres to send you events. So each time you notify stuff, you will have this. So it's kind of pub sub inside PostgreSQL. To be honest, I never used it, and I don't think it's a good idea to use it, but it can maybe be useful for some debug purpose. Also, in the replication system, now there is the point of quorum. So you will be able to say not remote apply, like if I want the transaction to be valid, I need it to be a remote apply. But you can say if there is only the first two nodes or any of these nodes who have the transaction, I consider it valid. Okay? So this is a way to manage a quorum system like in traditional NoSQL stuff. And you have the foreign data wrapper. Foreign data wrapper is something very big in Postgres. So you have foreign data wrapper for many things. They have various quality of code. But the point is, with foreign data wrapper, you can create a virtual table who actually take data inside another system. Another system can be Postgres. So, for example, you can request a Postgres using a Postgres and integrate parts of another database inside your own database. So it can be very interesting to merge some database without merging it. And maybe for migration and stuff like that, it can be very interesting. But more, if you use table sharding, to be honest, I never use table sharding on real life. So what I will show you is an example coming from a blog post I code underneath. So table sharding is the ability to say, okay, I have a table, I partition it using one point, and I create a sub-table, which is the actual table where the data is. And when you're using this kind of table partition, what's happening is if I just put some data in there, and I have the data from temperature, you will see that the data actually lay on two different tables. If you go further, and I know people who actually do it, if you use a foreign data wrapper using Postgres and the table sharding, you can actually shard and split a table across multiple cluster. You can build a cluster of Postgres with all the data not in the same place in the same time, which is really enthusiastic. Just remember with all this stuff is the database stability is driven by the predictability. So use to get metrics, learn and improve. There is a very cool software for this called POWA made by the people of Dalibo. I think it's a really good idea to use it. And if you want to try, Clever Cloud offer free plans of PostgreSQL. So it's just one-click launch. You say, I want an add-on and go on. And after that, your Postgres will be automatically updated, will be automatically monitored, will be automatically backed, like everything. You're using just Postgres as a service. And just it works. And it's now available with PG 11.1. And the auto update allow you to just push a button and say, OK, I will update my database. So thank you for listening. And I think I have the time for one or two questions. Thank you very much.